Welcome to today's Incubate Energy Lab Lunch and Learn. We're featuring Noteworthy and FirstEnergy today. The Incubate Energy Lab is built for startups to engage EPRI and electric power utilities in paid demonstration projects. This webcast is being recorded. By participating in this call, you consent that your name, voice, and contributions will be included in our recorded materials. Phones and computers have been muted on entry. To unmute yourself, please click on the microphone at the bottom of your screen, or if you're dialing in, press *6. For best connectivity, we suggest that you join the WebEx first and then have the meeting call you. We would like to have a very interactive chat and session today. Please go to the bottom right-hand side of your screen. Feel free and click on the chat button. Feel free to introduce yourself, ask questions, provide any comments, and please remember to select everyone. If you prefer to remain anonymous, please just send your questions to me, Angie Henniger. And now I'm going to pass it off to Chris with Noteworthy. Thank you so much.
Awesome. Thank you, Angie. And good morning, good afternoon, everyone. Thank you very much for joining today. Today, we're going to review and provide kind of an update to a project that we engaged with FirstEnergy on last year. As part of Incubate Energy Labs, where we mounted vehicle-based cameras and AI on the utilities fleet of vehicles to evaluate distribution assets at scale. So happy to review that in detail with you today. But in addition to that, we will provide an overview of our company, just kind of level setting who we are and what we do. We'll give FirstEnergy the opportunity to do the same. And then we'll dive into our project from last year and review a project that we're engaging with FirstEnergy on this year. So it's very exciting for us, very exciting for FirstEnergy. It's our next version of a project of our technology. Then we'll pass the ball over to EPRI to have a discussion and add some content in the context of evaluating distribution infrastructure. And we'll wrap up with Q&A. So about us, just briefly, the name of our company is Noteworthy AI. The AI stands for Artificial Intelligence. We were founded in 2020. We're based in Stamford, Connecticut, about 50 or so minutes outside of New York City. Despite being a startup and a relatively small organization, we've received a good amount of attention and have major utility customers, investor-owned customers that are interested in our technology. So of course, FirstEnergy, you'll be hearing more from them today, but also Exelon, Alabama Power, and a few others. We've received really good validation from industry leaders like EPRI, Techstars, Dominion Energy's accelerator, Joules Accelerator, which is Duke Energy. And we're also partnered with both NVIDIA and Dell on the technology side. And then lastly, we are venture capital backed. So just a few minutes on, again, who we are and what we do. So this will be the part where I talk a little bit more about kind of the challenge in the industry as it relates to distribution. I won't belabor this point because I'm sure many of the folks on the call today are probably more up to speed on this topic than we are even. But suffice it to say that there are billions of utility poles globally. Distribution, right? And our reliance on that infrastructure is growing exponentially. So, for example, the explosive growth of electric vehicles, the movement to electrify nearly everything, but also increasing our threats from extreme weather like wildfires and hurricanes, and an aging, crumbling infrastructure, particularly in the United States. So the question is the grid, and more specifically, the distribution grid, prepared to handle this? Now, unfortunately, the mechanisms that are used to answer that question today are often manual, labor-intensive, and costly. And for those reasons, they don't scale very well. So on average, when we have discussions with utilities, we found that about 10% of a given utility's distribution network gets evaluated annually. And there are a number of different reasons to go out and evaluate poles, which we can get more into, and I'm sure you're well aware. But suffice it to say that most utilities have little to no, I'll call it situational awareness on distribution, the condition of distribution infrastructure and more. And it's not their fault. It's methods, current processes that are in place to do it and have been in place for a long time don't scale, right? They're cost prohibitive. So our view at Noteworthy is that if we want to continue to rely on the grid going into the future, we need to find better ways, right? So at Noteworthy, we're leveraging artificial intelligence to help utilities collect and analyze data on their distribution infrastructure cheaper, faster, and more consistently than before. And the way that we achieve this is with a solution that we call Noteworthy Inspector, which is a platform for autonomous data collection and analysis that combines vehicle-mounted cameras, AI, and cloud software that works as utility vehicles drive during routine operations. So let me put a finer point on that, if I may. Our premise when we go and talk to utilities and present our ideas and our solution is that most utilities, especially large investor-owned utilities, have fleets of vehicles, thousands if not more vehicles, driving by distribution infrastructure every single day. And historically, that vehicle travel time, driving from point A to point B being the job site or whatever the crew has to do for that day, is unproductive travel time, historically, generally. And so why not take advantage of that travel time, mount our equipment on your fleet vehicles, and allow it to passively collect and analyze data around a number of different use cases, which I'll talk about during those routine operations with zero impact on the crew. Okay. And so if you envision one of our systems on a vehicle, right, we mount cameras, simply put, on the roof of the vehicle, and we'll talk more about that. But if one of your trucks is driving past a pole and our camera system is mounted, the system basically achieves three things at a very high level. It first geolocates poles. So it's going to estimate the GPS coordinates of each pole that it detects. It will then produce high resolution, low motion blur, low distortion imagery on that distribution pole. And then it will process with computer vision and other machine learning techniques that imagery in the context of a variety of different use cases. So what you're looking at there on the image on the right is what we would call a component detection model result or an asset inventory. And so we're enabling computer vision to process that high resolution image and enumerate all of the components, the pole top components, transformers, lightning arresters, insulators, cross arms, etc. And then we subsequently send that information to our cloud software so it can be digitized and made searchable. But asset inventory is only one use case for this technology. There are other use cases as well. Basically, anytime you go out and make a manual field evaluation or field visit to a distribution asset today, we can help, right, for the most part. So things like asset inspections or identifying defects in not only the components like blown cutouts, broken lightning arresters, but also in the pole itself. So leaning poles, burnt damage on poles, etc. Another use case is identifying areas where vegetation is encroaching on pole top components or on conductors. A third use case, which is always top of mind with a lot of our customers, is evaluating third-party attachments. So not just identifying third-party attachments such that we could detect unauthorized attachments, right? But also doing things like measuring for NESC clearance violations and pole load, things like that. And then lastly, but certainly not least, unregulated lighting. So helping utilities evaluate which portions of their lighting systems are legacy high pressure sodium such that they can more efficiently prioritize the work to go out and upgrade those to LED. But across all those use cases, kind of the key here is our ability to collect data at a low cost, at scale, across a large percentage of distribution. Because as you're probably aware, computer vision and AI is only good insofar that you have data to process. And the current challenge for many utilities is collecting the data in a cost-effective manner in the first place. So our core competency is collecting that data, and then layered on top of that cost-effectively collected data, we apply artificial intelligence to realize some use cases. And just quickly, some of the benefits of our solution. So number one, we're helping you to increase, again, I'll use that term, situational awareness as it relates to your distribution infrastructure, which in turn can help improve risk mitigation programs, increase grid reliability, resiliency, and safety. But also because we work during routine operations, our system is active during routine operations, we can reduce O&M, and it kind of depends on the use case in terms of how we reduce O&M exactly, but there are O&M reductions with our solution as well compared to existing methods. And the other key point, which actually ties into the O&M reduction, is the fact that we can address numerous use cases in a single drive-by. Because we run a lot of our models on the edge, our computer vision on the edge, it all can run simultaneously on the edge. So by that I mean today you might go to a single pole in a single year 3 times, right? Like make field visits. You might be looking for defects, you might be evaluating third-party attachments, and you might be cleaning up your GIS system, right? Or taking an inventory. And so each one of those field visits has a dollar amount associated with it and requires 3 separate visits. With our system, because we're running those models simultaneously, we're able to, in a single pass by of the vehicle, satisfy all 3 of those use cases, right? Address all 3 of those use cases. And the system works, again, during routine operations with no impact on the crew. So with that, I'll pass it over to Connor to talk a little more about FirstEnergy and their innovation program.
All right, thanks everybody. Chris, can you hear me?
Yep.
All right, good. Just want to check. So thanks everybody, and good morning, good afternoon to all those that have joined us. And first, I'd give a quick overview as to who FirstEnergy is. So I'm going to read this one just to get it right. We are one of the largest investor-owned electric systems, approximately 24,000 miles of transmission lines that connect the Midwest and the Mid-Atlantic regions, and a regulated generating fleet with a total capacity of over 3,500 megawatts. So that's on one side of the business, but I've spent a majority of my career on the distribution side, which is where we're going to talk a little bit more today. So this is our distribution footprint on the slide, where traditionally we had 10 operating companies, but we've since this year focused onto a state model. So we operate in 5 states: Ohio, Pennsylvania, New Jersey, West Virginia, and Maryland. And in that 5-state territory, we operate a vast infrastructure of more than 269,000 miles of distribution lines, and with over 6 million customers in residential, commercial, and industrial. And we are dedicated to providing customers with safe, reliable, and responsive service throughout that time. So that's just a little bit. We're headquartered in Akron, Ohio. I should mention that as well. But that's just a quick overview as to who the company is. And if you want to get into the next slide, we can talk more about the product innovation. So my role in the product innovation is, we want to create a best-in-class innovation pipeline. And the 3 things that we really look at are new product opportunities. Do we partner with platforms that will serve our customers and embrace disruptive technologies? And then we also like to deliver opportunities with significant savings or improvement to our company. Improvement is put in there as well, because not everything is a bottom line savings. We get things across the product innovation desk that deal with safety, and that will always fall top of the list when we get those. We'll evaluate those not based on a savings to the company, but a savings of potential life-changing events. So not everything is dollars and cents. Safety is always going to be one of the most important things we look at. But to accomplish these things, we have to break it down into some criteria. And we came up with 6 criteria that whenever a project comes across the desk that we look at, does this idea ideate and formulate new ideas for us that we can analyze? Are we able to invest time into a pilot to test out a thesis that we have? Does it improve internal processes or even metrics that we have? Are we able to create new intellectual property on this? Are there opportunities to educate ourselves and or external partners? And then can we collaborate with internal, other department business units or external subject matter experts? So whenever we get a project, when a project hits a couple of these, that's when it, kind of goes through the first stage gate. As you might imagine from hearing Chris's intro, this one hit a lot of these, and that's where that's why we kind of went forward with this one. we're able to do almost all of these things. You know, are we able to create new intellectual property? I think that was the only one that we didn't hit on this one. I mean, intellectual property has probably been created, but it was done outside of this pilot. So hitting 5 of the 6 was, you know, scored very high on our list. So we were really excited to partner with Chris and to really get some good data feedback and see if this proof of concept was going to work. So if you want to go to the next slide, you know, when you look at field data collection, this is a very manual, arduous process that takes months of prep time to determine what circuits need to be evaluated. There's a lot of manual work done. There's you know, almost the full year, you have full-time employees just, you know, getting work done, and then when they have some downtime, they fill in with some line inspections. When they go out and find a defect, depending on the conditions of the road that they're on or the working zone that they have set up, they may not be able to get a consistent picture every time of what a problem would be. So sometimes you see some inconsistencies with the problems. Other times, you know, you have to write up a report and you're not able to do that in the field due to safety conditions. So you either have to go write a report in a, you know, a parking lot so it's fresh on your mind, or a lot of times we get back to the office and then we write it from memory. And it's just the consistency of the process is, while it's okay, we know that there's room for improvement on that. Being able to collect the data in real time as you're just driving your vehicle really cuts down on a lot of that. And having the AI identify and flag things for you as well, actually may be able to improve the number of defects that we see. So as you can see, a process that is very manual and you know, you got to get in and out of your car, set up work zones, things like that. There's many risks that could go wrong. There's safety risks. There's you know, a lot of things that I just saw the ability to improve. So that's kind of the problem. The other thing is, Chris mentioned, you know, we get about 10% of our polls evaluated every year for inspection. In our innovation process, we go through a challenge and say, how can we improve that? And one of the things that we did was we want to test, you know, of our 4 million polls that we have throughout our service territory, are we able to go from 10% to 100%, or what's the time frame that it'll take us to get there? So those are the types of things that we look at when we go through an innovation project like this. Is, you know, what kind of improvement are we going to get from a baseline to an improvement? So then so we can dive in. So Chris and I will kind of go back and forth, I think, on these. But last year through the Incubate Energy, we had a project overview that we wanted to demonstrate the approach and really understand what kind of improvements, as I said. So we took 2 locations in close to our headquarters, one in Akron, Ohio, and one in Salem, Ohio. Akron is a more urban setting, city feel, where Salem is a more rural country feel. We were able to install the Inspector Edge on 2 utility vehicles, on trouble trucks that would drive from job to job. We were able to document the analysis and inventory requirements. We were able to collect and label the vehicle mounted imagery, and then we were able to field test the Inspector Edge performance on the segments of the distribution with the pole locations and configurations with the overhead components. So we had a great overview to start the project. Next slide. Chris, you want to talk about the vehicle installation here?
Yeah, so as Connor mentioned, and I'll add just one point from our perspective. Like, when we engage with utilities initially, you know, we want to give utilities a mechanism to validate our technology in a very low cost, low risk way. And that's the intent, right? Because, you know, AI in general, there are a lot of claims out there, and we want to prove to the utility that there's value here, right? In a system as such, and more specifically our system. So we start out with a low cost, low risk mechanism to do that. And in this case, for FirstEnergy, it was to really evaluate distribution in the context of taking an inventory and helping to clean up GIS. And as part of that, there was some additional model, AI model training that we did. But ultimately, the first step, whenever we engage on a project, is to first make an assessment of what types of vehicles we're installing on. Now, in this case, we're installing on two 2011 vintage, actually, Freightliner M2 bucket trucks. And that certainly was not without challenge. But if you look at some of these photographs here, we have a camera system. There are a number of cameras. There's kind of an antenna array for GPS and Wi-Fi and things like that. That all mounts on the roof of the cab, typically. And we have a number of different mounting options. We can use industrial strength suction cups, magnets, and roof racks as well, which is what we did in the most recent project, which I'll talk about. But ultimately, it's all about making the installation non-intrusive and non-burdensome on the fleet team, right? Because we acknowledge that people have day jobs and they don't necessarily have all day to spend time trying to figure out how to install our stuff, right? So we make sure we do it in a non-intrusive way. We have a plethora of mechanisms and options in terms of how we install, and we try to make it as seamless as possible. So in this case, cameras mounted on the roof of the cab, suction cup based system. You'll notice that there's a bundle of cables kind of coming out of the back of this unit. Those route down, in this case, to the rear of the cab of the vehicle, which in this scenario, there was a vent, a plastic vent that we're able to pop out, through, insert our cables through that vent so that we can get them into the cab and water seal it so it doesn't leak. And then inside the cabin, in this case, it was behind the passenger seat in the cab, we have a computer. So as I mentioned, 99% of our AI is running on the edge, and there are a variety of benefits to that. But to do that on the edge, we need a computer, right? We're not just collecting imagery that you then need to, kind of sort through later. It's all done on the edge. So that camera system mounted behind the passenger seat, and we integrated with a cigarette lighter adapter actually on this truck to power the system. Now, this is one of our earlier installations about a year ago. We've since improved in a number of different ways. One of which is we don't integrate with cigarette lighter adapters anymore. And so future deployments, and our current deployment with FirstEnergy that we're engaging on this year is a bit different, and we'll go through that. But that's how the vehicle installation works. It's actually a pretty seamless process, and we don't require any drilling or anything like that in the vehicle.
So, yep. So for our project, we were able to do some really cool things. That the first thing that we did was the pole detection and the geolocation of the poles. Through the pilot, we really wanted to set some goals as to get some numbers established and things like that. And we were able to improve the detection of poles to I don't know where we started, but we ended at well over 80% of the pole detection. I believe it's even gotten better since then, where 80% of the times that we drove by a pole, we identified it correctly. And not only were we able to identify that the pole was there correctly, but we were able to do it within about a 3 meter or 20 foot of the GPS accuracy. So to us, 3 meters is a pretty good indicator that not only are we finding the poles that need to be there, but we're finding them in the right spots. So that was some major success that I thought we had in this first pilot.
Yeah, and then just kind of double clicking on that, this is more of a zoomed in view of what you saw on the previous screen. So on the image on the left, it's just showing the existing GIS that FirstEnergy provided out of their GIS system. So the olive marker, and if you can make it out in the image, there's a pole here. The olive marker is where the pole was documented in the GIS system. The red marker, for whatever reason, is actually meant to reference the transformer, which is on the pole, but it's back here. Now, in our scenario, and the output of our system, if you look at the image on the right, it's the yellow marker, right? So we're very close to the olive marker. So that's the yellow marker of the pole. That's our GPS coordinates that are estimated on the pole. And then, we did more beyond that, which we'll talk about.
So the other things that we wanted to talk about, and as I mentioned earlier, when the inspectors are out in the work zone, depending on conditions or weather or whatever may be happening, they may have to snap a picture real quick with their phone or even a digital camera. What this pilot was able to accomplish for us was standardization of data capture, which it may not really seem like it's all that important, but when we were able to compare the original images that we had in our GIS to the standardization, having the same 2/3 of the pole that we were able to get, it makes it so much easier for the inspectors to go back and then reference where they were, what pole it was, and then oh yeah, this is where I was. And they were able to write up a report a little bit easier. So not only that, but they're also able to get super high resolution. So if you find a broken fuse or a broken cross arm, or one of the lightning arresters is hanging off, I believe, Chris, correct me if I'm wrong, we were at like 20 megapixels for the camera or over that. Yeah. Yep. So we were able to zoom in and get very clear imagery of very small components that you can't see, from just a normal picture.
Yeah, for sure. And so I want to underscore here how much work and give kudos to our internal team at Noteworthy for developing this camera system. Because when we kind of naively started out 2 years ago on this project, we're like, okay, the AI is going to be the most difficult part. And it is, right? It's complicated. There's a lot of fine tuning you have to do there. But what we neglected to fully realize early on was how difficult it would be to optimize the camera system. So if you think about what we're trying to achieve here, right, there are many variables that impact a camera system's ability to produce high resolution, low motion blur, low distortion imagery in this scenario. So for example, the velocity or the speed of the vehicle and its rate of acceleration or deceleration, that can all introduce blur, right? The faster you're moving in the imagery. And that's something we can't predict at any given point in time. We don't know how fast the vehicle is going to be moving. Similarly, lighting is a concern, right? And that's forget AI. If you know photography, lighting is key, right? That's that is the most important thing. So here we also have variabilities around lighting and weather, which impact lighting. So the sun might be in the top dead center, right? It could be noon. Could be dawn, it could be dusk, it could be an overcast day, it could be a bright and sunny day. We don't know at any given point in time. And so all of these variables impact the quality of the imagery that we output from our system. We wanted to maximize that quality. So we did a lot of work to optimize the system, the lens selection, how we control the cameras with AI, with software, the shutter speed, things like that, to produce that high quality, low motion blur, low distortion imagery from a moving vehicle with no driving restrictions. So we're pretty proud of that. And again, AI aside, just having this imagery, right, and being able to consistently look at it can answer a lot of questions for a utility, right? So that's key to our system. But beyond the imagery, right, the AI does provide value, and a lot of times it's enabled because of the quality of the imagery. So again, in this case, it was, we're field testing kind of an asset inventory scenario. So we deployed an initial version of our model, and that model's job was to kind of enumerate all of the pole top components. But as part of the data collection process for this project, and this project, by the way, was about 3 to 4 months long, we wanted to take advantage of all the data that we collected to further train the model to make it better. So what ultimately we did for this particular model is that we started out with an mean average precision, which you can think of as like accuracy. We started out with about an 81% accurate model across all the different types of components that we might identify. It's doing it correctly 81% of the time, and then moved to 90% at the end of the project. So from our perspective, this was a super valuable project as well because it helped us to improve our AI.
So here's where I got really excited when Chris started showing some images of what's out there. This to me was kind of a small subset of the things that we found when we came back, and we're able to take a look at all the things. One, we were able to find, you could see how clearly you could see missing fuses, corrosion on transformers. These are things that you may drive by a certain transformer and corrosion's it's going to happen, but you can see is it happening faster over, if you can compare picture over picture, 3 months apart, that may indicate that something's leaking, versus just normal corrosion where, over 5 years, it goes, another inch or so. So, those are things that, you can put on a flag, monitor it, make sure it's not leaking. Vegetation overgrowth is another big one. There's a lot of talk in the industry about vegetation and where to get it, but having a picture like this and saying, yeah, at this location, here's the veg, we need to get someone out there to trim the trees. And now, although there are two components to pole inspections, you have a physical inspection where you go out and tap the wood and drill into it. You can also maybe accomplish some of the visual inspections and see, like that last picture on the right here, how bad is the wood splitting at the top? Where is the major defects in the poles? Again, it doesn't replace the entire pole inspection in terms of the physical aspect. You still got to have someone go out there and get their hands on it, but we may be able to supplement some of the visual inspection that is done as well. So as you can see, these pictures are invaluable to engineers that are back at the office that need to see, what's the condition of our assets out there.
Yeah, and these images were hand selected. So these were not selected from any of our AI. Again, the intent for this project was inventory. But throughout the inventory, as we were reviewing that imagery, we're like, okay, here's some scenarios of missing fuses, vegetation overgrowth, et cetera. And over time, and we do have some of these models already, we're using data such as this to train those defect or vegetation overgrowth models, such that they could be deployed and used in the future. And in fact, that's what we're working on our next project with FirstEnergy, which we'll get into. But again, just the value in having that consistent imagery, like this image on the left with missing fuses. You'll also notice that there's I guess 6 phases here on this pole, and one's going off to the right, one's straight. Like there's value in knowing that, and that's something you could deduce by looking at an image. And then also this asset identification, ratings, serial numbers, asset tags. Because the imagery is such high quality, we can then extract and digitize and make searchable, asset identification or asset identifiers in a scalable way. So there's a lot of value in the imagery in general.
So the outcome of our pilot, before our engagement with Noteworthy, we were able to download all the pictures that were in our GIS, and there were about 934 images. Again, they span multiple years. Some were taken with a digital camera, some were taken with digital phones, but there wasn't much consistency. We had pictures of a zoomed all the way into just the problem on maybe a lightning arrestor or a fuse. And then we had some pictures that were zoomed all the way out, and you kind of had to go search for the problem. So that was kind of the as is. But then what we were able to do during the pilot was we were able to capture 5,000 images collected, and that's Chris. Again, correct me if I'm wrong, but that was the end result. Not including the ones that we got rid of. Correct.
Correct. Yeah, that's the key. It's not. This is not. We're inundating you with data that you then need to filter through later and say, okay, this subset are polls, right? We're doing all of that pre-selection, if you will, on the edge. So those 5,000 images corresponded to 1,650 polls that were identified and geolocated. So we had multiple images on each poll for about 1,650.
Yeah. So that's a big jump in what we were able to see. And then, what I thought was kind of cool after that was the things that we didn't account for from a FirstEnergy standpoint. Again, we were looking at defect identification and asset identification, but then we went into hey, We can look at veg management. We can look at third-party attachments, all from the single image that we already collected. So to me, that was kind of the aha moment where I said, man, this is really, really powerful things. And then the last bullet during to be repetitive, this was all done during routine maintenance, O&M from trucks going from job to job. So this is all, in my opinion, a benefit because we weren't doing that before. So that would be, being able to do that just driving from job to job is going to be another powerful savings in my. I think we're going to be able to quantify that savings a lot, but and then afterwards, so the product innovation group, we put together an evaluation and said, hey, I think this is worth it. So in our process, I sit on kind of the unregulated side. So this is one of those instances where I have to pass it off to another side of the business, and then they run with it from there. So Chris, I'll let you talk about where you guys are going with the regulated team after this.
Yeah, thank you. Thanks, Connor. So, I'll just skip right to the next slide. So basically, we just about 3 weeks ago actually kicked off this project, and it's from basically July until the end of this year. And what we're doing for this project is we're installing on 3 fleet vehicles, in this case, not bucket trucks, but as FirstEnergy would call them, circuit patrolling inspector vehicles. So they're Ford F-150s. And the whole intent here is to leverage those circuit patrolling inspections to collect what's called ground truth in the AI world, such that we can continue to train our models to identify defects more effectively. So in other words, these inspectors will be driving out anyway, right, for the remainder of this year, driving by distribution infrastructure, making their own visual assessment as to what the defects or other anomalous conditions are. We're going to compare that to the imagery and the GPS coordinates for those images for each pole that we've identified, because we're installed on those inspectors' trucks, and use that information from the inspectors to then annotate the imagery and use it to train a defect model to again make it broader in scope in terms of what types of defects it can identify and more accurate as well. So that's the intent of this project. As I mentioned previously, vehicle installation, we had a lot of learnings from last year's Incubate Energy program with respect to installing on vehicles, and then also with other customers as well, quite frankly. And in this case, as I mentioned, we installed on 3 Ford F-150 trucks, so just the dynamics of the vehicle are different from last year. We focused on improving our system, our camera system and compute system in a number of ways, primarily electrical, because integrating with 12-year-old or 11-year-old bucket trucks on their cigarette lighter adapters isn't the best way. There's a lot of spikes and lack thereof in the voltage, and that can wreak havoc on computing systems. So in this case, what we do is we tap right into the fuse box, and we have 2 taps right into the vehicle's fuse box. One is for an ignition sensing fuse, so it knows when the vehicle's ignition is on and off. The other is for just an always on power fuse, so even if the ignition's off, the power's there. And so basically it's very seamless. The ignition goes on, the driver starts the truck, our stack starts up, and then when the ignition goes off, our stack detects that because of that ignition sensing fuse, and we leverage the always on power to gracefully shut down our system. And just the fact that we're getting power from a fuse box means it's more consistent and reliable, so that worked really well. Additionally, we chose a roof rack mounted option this time, so again, non-intrusively, these things remove quite easily. And we bolted our base plate for our camera system onto the roof rack, and then we leveraged a port or a grommet that already existed in the back of the covered bed. So this pickup truck has a covered bed to route our cables into our compute system, which is on the floor of the bed and protected by kind of a shelf that's in there. So a lot of improvements on the vehicle installation, and that process went well. Now on the ground truth collection, and I know we're getting close, I don't want to give Bepri some time, so I'll move a little bit more quickly. if you look at the image on the right, just to summarize, these are the types of defects that FirstEnergy's circuit patrolling inspectors are looking for. So as we focus in this project on collecting that ground truth, these are the types of things that we're looking to the human inspectors to identify for us, such that we can then reference the imagery that we collected for those same poles and say, hey, here's the conductor damage or excessive slack on the conductor or a broken guy wire or whatever it is, right? And so again, the goal is to leverage all that information, train our models, and then field test those trained models over the next 6 months. Now, in terms of current status of the project, as I mentioned, we kicked it off 3 weeks ago, so there isn't all that much status other than we deployed our 3 edge units and field data collection has begun. So we check in periodically on those devices, we extract data from those devices, make sure everything's running well. But as the project continues to go on, we will collect data off of it and start looking at the ground truth, and we're really excited about what we're going to see there. The other point I want to quickly make is that part of this project, we're going to leverage the collected imagery and pole coordinates for other uses outside of defect identification or inspections. So FirstEnergy has a project that they call ADAPT to refresh all the data in their GIS system. So we're working with their GIS team to supply pole coordinates and imagery in the context of refreshing GIS. Also, and this is kind of a variable, if significant storms occur during the project, and hopefully they don't, the utility wanted to be able to assess our system's ability to facilitate damage assessments or storm response as well. So that's a bit of a variable piece where if those storms do occur, we'll look at what we could do there in terms of data collection and model development. And then the last point I will make is that we're doing a lot of LiDAR-like stuff, for lack of a better term, without the restrictions and the requirements typically expected of LiDAR-based systems, right? They're really expensive. They have serious restrictions on how fast you can drive. And for those reasons, it really doesn't scale and utilities don't do it all that often. So we're taking a vision-based approach to generating point clouds and ultimately depth information that allows us to do things like take measurements, right? Measure the distance between electrical components and third-party attachments for NESC clearance, or measure the distance between a tree branch that's encroaching on a conductor or on a transformer. Those measurements and doing that accurately is very important, but also important is that we can do it cost effectively at scale. So much in the same way that Elon Musk with his autonomous vehicle systems on Teslas, they're taking a vision-only approach. They don't use LiDAR or anything like that, and they have the best system out there. We're doing the same for utilities, right? It's a vision-only system, and there are a bunch of benefits to that. So as we continue to develop with FirstEnergy and other customers, we're moving in the direction of these measurement-based use cases and applications. So with that, I will pass it over to Drew over at EPRI.
Thank you. I am filling in for Dexter Lewis, as you see here on the slide today. Dexter's been involved in this product through the Untitled Energy Labs, but he wasn't able to join us today. So I'm going to give a little bit of the EPRI perspective on the technology and how we see it progressing. I'm sorry, I seem to have messed the slides up there. So I'm not sure who had the slides to start with.
I'll put them back up.
Okay. By way of background, I'm in the distribution assets research area here at EPRI. What we do every day is we're looking for opportunities to improve how we interact and how the assets of the distribution system are managed over the course of their lifespan. We focus on overhead assets, underground assets, automation. We do work on safety and work practices, topics like arc flash and grounding. We also do asset and reliability analytics using data to make better decisions about the assets. We operate labs in Charlotte and in Lenox, Massachusetts, where we do a multitude of testing on all sorts of different distribution equipment. And we interact with lots of utilities naturally, as as we do this. In the distribution program, there's more than 40 utilities participating in the research from all across the globe. So when we interact with those utilities, we hear a few common themes, and one of them is O&M, pressures on O&M budgets and the need to reduce that, while also not wanting to sacrifice reliability or resiliency as we do it. There's a theme that pervades a lot of what goes on of making our existing workforce more effective and more efficient, and making more data-driven decisions, specifically decisions around assets that are objective, based in data that's been collected and analyzed from the system itself. So that gives a little bit of background into what we do here in the distribution program here at EPRI. If you want to move on to the next slide. When we think about this technology in this approach, obviously at EPRI we're vendor agnostic. So I know we've heard from Noteworthy today. My comments are really going to be about the concept in general, less about Noteworthy's implementation of that technology. There's a few things I wanted to highlight. Three groups of three, pros, cons, and some unknowns that we need to learn more about. So first, the advantages, the pros of the technology. Obviously, based on what we've seen today, and I will say this was an extremely interesting and insightful session, so I appreciate the previous presenters here. It was interesting seeing the passive approach to monitoring and data collection. The ability to gather more data without adding additional burden on the people that are in the field, I think is a very interesting and a good approach. With that is the intelligent data analysis that we saw, because those go hand in hand. We've got lots of technologies out there that can collect data. It's great when we can do that without having a person in the loop. But if we rely on more people to analyze that data, we're still impacting how fast we can do that work and also the cost of the work. So I think some pros around this technology, passive data collection and background data analysis, I think is really, really great. Some things that are inherent to this approach that we need to be mindful of that could be limitations. One is the limited perspective of the pole. Obviously, by the nature of where the camera is and how it's taking the pictures, you're going to have that ground view from the ground looking up. Obviously, like the picture you see here on the screen, you can see a lot of what goes on a distribution pole from the ground. That's where a lot of inspections are performed today. So we're getting an apples to apples with a lot of present practices. But more and more, we're seeing technologies like drones and satellites and aerial methods to get a top-down view of the asset. So one thing to remember is you will be getting a limited field of view from this type of technology, and also being confined to the road. I think it's really great to have that passive approach like we talked about before, but the other side of that coin is you're only going to see the assets that you naturally are driving by. So I think there's two sides to that pro and con coin there. And then some unknowns. A topic that we hear about all the time at EPRI is what's the value and how do we quantify the value of a new technology? It's one of the most frequently asked questions that I get, and it's always one of the hardest ones to answer because there's just so many different ways to approach quantifying the value of a new technology, whether it's avoided cost or whether it's the value of adding additional inspections. There's lots and lots of different ways to slice and dice the value equation. And then one thing that we haven't seen yet that I think we're going to be learning more about in this phase 2, which I'm really excited to see the new developments in the phase 2 project that we just heard about, is how it can scale. One thing I've learned in my career doing new technology pilots and research for utilities is just how big the the utility system is, especially in distribution. We kicked this session off talking about just how many poles there are out there globally. I think the number on the slide was more than 1 billion poles globally. Those numbers are hard to fathom sometimes. And the scale that we're expected to look at assets on the distribution system is quite large. So I think it's going to be important to keep track of this technology and frankly have more sessions like this where we get updates on phase 2 and phase 3 and phase 4. As the technology grows and as it scales, so we can see it operating at the scale it needs to really have maximum impact. So those were three comments I wanted to inject into the conversation there. Some pros, some cons, and some unknowns that are still needed in the R&D space. I'll close with my last slide with a reminder through the Incubate Energy project that you heard about today, through the research that we do in the distribution systems program at EPRI. We do pilots and demonstrations like this a lot, and this is a technology that we keep our eye on, and we're excited to do more demonstrations where we start to uncover some of those unknowns about how can you quantify the value, how can you ground truth it. We heard some about that today, which is great, and then how do you really quantify performance. So EPRI has, I think, an important role to play as this technology matures and approaches the scale that we're going to hopefully see it operate at in the future. So we're going to be staying involved with this through the pilot phase and hopefully do more of these pilots in the future. With that, I'll turn it back over to Chris.
Awesome. So thank you very much, Drew, and Connor, of course. Thank you, everyone, for joining today. I think at this point, we have about 5 or so minutes left, and we'd like to field any questions that you have. So for that, I'll pass it back to Angie. Thank you.
All right. Let's see. Do we have any questions in the chat? Let's start with, did you use bucket trucks because that was who was currently doing the inspections, or was there another reason for that?
I can grab that one, Chris. So the reason why we use the bucket trucks were we used what we call troubleman trucks. And that was because they're the ones that are most active out in the field for that pilot. We thought if we were going to get, 2 vehicles, we want to get the vehicles that are out on the road the most, and the trouble trucks were the ones that doing that. So I think for the second one, from what you heard in the pilot, they're on the second pilot, they're going to be on the inspectors trucks. But for that first one, we just wanted to get as many miles as possible. So the trouble trucks were the way to go.
Let's see. Is your AI application running on the computer in the truck or in your data centers? And how many servers are needed to host the AI application for your use cases?
Okay, yeah, I could take that one. So, as I mentioned previously, most of our quote-unquote AI, right, the machine learning parts run on the edge. So directly on those, we have a large amount of compute available and storage available on those units, such that we're able to run multiple models simultaneously, like I mentioned previously. And the benefit to you is that less information later to review. And so, yeah, the majority of that AI happens on the edge. There is some AI or machine learning models that can optionally be run later in the cloud. So let me also say that as our systems detecting poles and geolocating them and taking images and running those initial models like an inventory model, those results, there are a number of ways in which we could get it to our cloud software. One is like real time over cellular connection. And so once the data, though, are in our cloud software, we can then do things like run an OCR model, right? Optical character recognition, to be able to extract and digitize asset identification, right? Asset tags, serial numbers, et cetera. So majority of it on the edge, some of it optionally in the cloud. How many servers we have on the back end is dependent on the size of a deployment. So by default, we host everything in our cloud, right? Our cloud software is in our tenant, if you will, in Google's cloud platform. So they're, cloud platform, it's scalable, scales up as, based on demand, essentially. So it's a variable thing. But we do have, as I mentioned previously, this partnership through Dell, because oftentimes, quite frankly, sometimes utilities don't want that data in the cloud, right? It's kind of critical or close to critical asset information, and especially some startups cloud, right? So we have the ability through this partnership with Dell to take our cloud software and allow you to run it on Dell hardware on-prem, so in your own data centers. And the size of that on-prem hardware footprint is dependent on the size of our deployment, how many edge units are deployed, things like that. And so that's something that we would work with the customer on a case-by-case basis to define.
Okay, let's see. One more question. What is the top speed for vehicle acquiring data? Is it 65, 70, 75 miles an hour?
Sure, great. I'll take that one too. Great question. So basically, so as I mentioned before, we did a lot of work on optimizing the camera system such that it works in a wide variety of conditions. The speed of the vehicle, while we have no artificial cap, let's say, on how fast the vehicle can go, what we have seen in practice is, upwards of 65 miles per hour. We'll start to see some motion blur sometimes in the imagery, and it also depends on the lighting on that given day. But ultimately, the only time we run into an issue is when you're really going, fast, like 70 plus, and that's going to happen on a highway, and there usually aren't poles on the side of the highway, right? So for the vast majority of driving, there is no restriction. There's no artificial cap on how fast you can drive.
Anyone else have any questions? No? Okay. Was there anything else that you all wanted to discuss before we close this call out?
I think I would just say thank you again, both to FirstEnergy, EPRI, and to everyone who joined the call today. We love to have discussions with you and showcase what we're doing, and thank you for the opportunity today to do so.
Yes, I echo that. Thanks everyone for joining the call. I appreciate it very much.
Thank you, everyone. We will give you, I guess, no time back in your day. We will end out this call, and I will have everything posted to the Incubate Energy website shortly. Thank you.